So, brightness and contrast, I believe, I do not think to repeat, this is only for general. You can add a constant value to improve the brightness or reduce the value by going dark, so values. So, you can have less brightness or more brightness, it is just adding a constant. Contrast also is something, as you can see, the formula say new value means you take a old value of the situation, the values in the function, and reduce, subtract and multiply by a contrast value and add the same thing. The idea is that if you keep contrast as 1, you will have no change, otherwise you can manipulate less than 1 or more than 1. So, you can reduce the contrast or you can improve the contrast. Basically, contrast simply, as you can say here, is you can stretching the range of interest or reducing the range of interest. So, many situations, this is again enhancement that we will not be using for applications, this is only for enhancement. Again brightness plus contrast, this is only, that is why I was considering many of the point operators. We are in fact, I think I missed to recall that these are point operators, means they are occurring at a point, they are not considering the values of neighbors, they are not considering the values of the functional values nearby. So, they are not considering any locality as such, they are picking up individual and attacking on it. So, whatever change is occurring, as you can see, the functions are showing thresholding or brightness or contrast, they are not taking care of the neighborhood processing. So, they are simplest and they are dangerous as well. Many of them are enhancement ones which are not used for applications, and only one, as I mentioned, is the thresholding, which is also to be used rarely as a method of say segmentation from the background. So, otherwise edge detection and other methods are suited for segmentation, which means that you try to extract objects of your interest from the background. So, that is the segmentation process. So, inversion is again just changing the shades from say value to minus, say if you have something value say x, you say 255 minus x. So, basically inverting the value. So, that is why you find something like negative of a film kind of behavior here. The results here shown are for color, but actually which I have not disclosed yet the detail of color processing, which will follow afterwards. In this case the examples are showing all color images, but some of them are indicative of black and white. So, basically what is happening is we are doing 3 color processing here and showing you the result as a combined 3 color result. So, just to give a appeal of the result, the results are color, otherwise the effects are actually three image processing functions are occurring. So, gamma is something, if you are not aware, most of these are available in monitored correction also. These functions you must have seen. It is a gamma is a function which actually exponents the old value. So, it is assuming that or 1 minus gamma is basically the value. So, to correct it is assumed that some functional exponent changes have occurred. It is again our assumption that instead of linear, it has follow an exponent behavior of the original information, and to correct it we do a 1 minus in kind of gamma correction. This is called gamma correction. The gamma correction is some value nearby. If it is 0, you can have no change. If you have something else, even your monitors will have all that. These are for display purposes mostly used, but it is also assumed that the sensor, the camera, the CCD, any acquisition system also can have gamma problems. Again, this is only to compensate the visual appeal. This is also not required in automation on applications kind of. This is only if the appearance is not good, this is to correct the appearance. Now, this could be again some of some interest as a function, like we showed earlier. Thresholding was kind of abrupt behavior, like a non-linear 0 to 1 kind of situation, where a particular value below a particular value was all 0 and above a value was all 1. In this case just shows a typical that up to a certain value you have some gain and the other value you have some other gain. So, in a way you are brightening up the other area, say beyond a particular value. Say in this case the value junction point here is somewhere in the middle. So, you can basically have any curvature here also. The systems provide changing of appearance by way of any curved functions as well. So, these are levels and curves. You can not just have 2-3 points on the level, you can also have a curved behavior, that this is the way you would want output to have in comparison to input. So, this is again you can fix, say, input black level should be this, given the input black level, given input white level, say the range is not full. Particularly this happens in medical images. For X-ray images, which are actually 12-bit kind of images, they do not have usage of full band, full range of, say, 12-bit. So, depending upon the energy used, which you can simulate in your mind as illumination on the body, some of the area is used in the whole band is fully is not used. The idea is that you will find that X-ray image is not visible at all, but actually the information is there, right there. So, if you bring it to the visible range of your monitor or the process that you are using, so it may become visible. So, the idea is out of the 12-bit, say 4000 shades, only 255 shades are visible at a time, or more than that are visible, but human eye will not be able to perceive that. So, such functions are required to bring, it is like you are illuminating a particular dark room. In this room, suppose you have a torch, you want to move this area, you move to the other area and then move to the other area. So, very much similar situation occurs in a 12-bit kind of images for medical applications, where you all cannot see 12 bits at all. There are large number of levels, but they are required to see the body information. So, at a time you see only a part of it, you can't see the whole thing, because your visual system is not designed for that. So, even your displays are also not designed beyond that. So, some kind of lookup tables, some kind of level adjustments are required again for enhancement when visual appeal is required. Okay, segmentation, I have just listed them here as categories of situations. Basically, we want to detect the discontinuities. We do not say that we want to extract objects, which is actually our interest, but we are trying to define as if, okay, we want to see mathematically how the function is varying, how the things are delineated from the rest of the other objects or background. And sometimes it requires the edges are broken. Thresholding is already given as one method, and region oriented segmentation is also actually related to simplest thresholding or other methods of thresholding. And sometimes through motion you can detect, suppose on a background like that, say, which is uniform, somebody is moving. So, you can use that motion as information and other things as background. So, assuming the background is not changing and only the objects are moving. So, in that situation, whatever is changing in a frame by frame situation, you can detect that kind of motion as information for segmentation. So, this is just to give you again, not that I am giving detail of these applications, these are part of the processes. This is just a kind of foundation for filtering. Now, actually we spent some time on neighbourhood operations, which I mentioned the point operations do not have it. Now, the neighbourhood operations are where you can say digital filtering is actually occurring, wherein we are considering not just one pixel, but pixels around the pixel also. So, pixel of interest is in the center, as you can see the blue area here. Here the central pixel is of interest and all neighbors are considered for processing of this. This is spatial filtering, and you may recall now, by now we have not discussed Fourier kind of filtering at all, as you must have felt. So, most of the filtering that is occurring in image domain is spatial domain filtering, just because humans are comfortable, human mind works in that way, unless it is a typical situation where Fourier domain is of help and people have become conversant with that. So, mostly you will find that the spatial operations are done, and they, as you can see, mathematically are equivalent to Fourier domain analysis. So, strangely in signal processing we use Fourier domain, Laplace domain and Z transform domain kind of approaches. Here we use neighbourhood or spatial filters designs, wherein a particular mask, or as you will see, basically a mask is something like blue mask here showing here, where the neighbourhood is under consideration. It is like how much of neighbourhood gets utilized in. If you know the digital filters also, you know there is a neighbourhood consideration in signal processing as well. So, you can see the idea here is that while processing, do not just assume that it is the pixel being processed is of interest only, other than it has no meaning basically. You will apply some rule as we said in thresholding and try to get everything in one go, but that is not the way the information is extracted. The information is distributed among all neighbors. So, that is the idea here, that the neighbourhood processing will maintain relationship with the neighbors. So, the red pixel here actually shows the pixel of interest, and a 3 by 3 mask as we call it is of consideration while the result of this processing is being done. So, the result output could be the right bottom there, wherein red is marked that this pixel value will be altered by the process and the others will be considered for it. That is the idea of locality consideration. For example, when we said thresholding, we were not considering any neighbor at all. We just had some analysis, we did have say statistical analysis by way of say histogram computation in advance and choosing a threshold, but whatever threshold we chose was a statistical choice for all of them together. In this case, we are not actually doing the thresholding right now, but the idea is that whatever process we are doing, we are considering the say 8 neighbors around it. We can have even larger masks, that is choice of the filter design. So, in this case it is just showing that a small area around the particular pixel of interest is being considered. Now, some of you, if you have tried such filtering, you might assume that what will happen to the border ones. So, what will happen to the edge handling, with basically edge handling or border handling I would say. The border problems remain all over, here also we face the same. The common approach is that actually you do not have data on say, it is like causal and non-causal kind of situation, where you do not have any data before the image was acquired. So, if you require the neighbourhood at the border, you have no neighbourhood. So, the one on the corner does not have a neighbor on the other side. So, in this case the idea is that either you use them as transparent, means kind of transparent as if they do not carry any kind of information, or you give them a black information, or give them a particular color of your choice, or you choose the nearest neighbor, that okay, whatever is the last we copy them as layer. For example, in this case you require 3 neighbors, we may have the same neighbors as their own values. So, these are of course choices depending upon what is suited to you, but generally there is a problem, and many times we say okay, let us wrap them in the sense when we look for these 3 neighbors on the left hand side, we may choose these neighbors as if they are the neighbor on the other side. So, like 0 degree situation, 360 degree full turn is taken up for the image. These are of course just the handling situation for those who actually get involved in it. Now, this shows just the effect of say convolution. Now, the whole process of neighbourhood processing is called convolution. I do not know whether it is making a sense or not. I think all of you are comfortable with understanding of convolution in time domain for say one dimensional signal processing. So, it is something very much the same. The filter design has to have either multiplication in frequency domain, or in this case spatial domain will have to have convolution. So, the mask that we mentioned is actually moved across the whole image every time considering one pixel as center of that mask and then taking the commuted sum of that. So, the mask values say let us assume that the mask is all 1 1 1 1, all 9 as 1 values. So, in that case we are multiplying 8 neighbors and the pixel of interest and then joining them, summing them together. So, it is a sum of products of 9 pixels considering the central pixel as well. So, that process once it is repeated all over the image generates a kind of low pass filtered image or smoothened image as we call it, as one of the simplest convolution process. So, the mask design is the designer choice, again depending upon the need and application. The convolution process is similar to the multiplication in frequency domain. So, in this case it shows some effect, as you can see some kernel or mask are used the 3.3 matrix that we mentioned is a kernel, also a term used for the same filter design, is a two-dimensional entity. Is actually like an impulse response. Those of you are all familiar with the impulse response. Basically, the kernel here is an impulse response, where the impulse response is centered at the center of the pixel. So, when with that mask, when you convolve the whole image, the result is something like what you see in the right here, or anything that follows as effect of convolution matrix. So, that is the kind of process we do for spatial domain filtering. I am not giving the detail of the design of this, I just gave you one example of say smoothing filter, which is say all one values, and of course, you have to divide by the sum of that mask values. In a way, it should be all 1 by 9. It is like averaging basically. What is averaging? It is like it is a moving average kind of situation. You get a point, take an average, move to the next pixel, and then average. Basically, you are reducing the variance. Simply, you are reducing the improving the signal to noise ratio by way of convolution, which is simply averaging the neighbourhood. Now, this is something, the effect of that you can see. Now, who will say this is enhancement? The right hand side is the end result of the left hand side. Now, what is the purpose? Why are we doing this? To remove noise. I do not know if somebody says there is no noise in the left hand side image. Is there? Maybe signal to noise is also improved, but sometimes there is no noise or visibly there it appears to be say noise free, though there may be some quantization noise. But overall end result is even if we have improved, what have we gained in it? What the idea is that is why I am raising the issue. I told you we are degrading many times. It is like simply sometimes I say food processing. When you process the food, do you get the better food or worse food? I do not know. If finally if somebody gives you a vitamin for orange, is that a better food or a? So, it is the same thing we are doing, but that may be our interest to say extract vitamin C from say citrus food. But that is the process, that is the whole process is actually degrading, but it is extracting something of interest. Degrading in a broader sense, but actually improving the information or the content of interest and killing the rest. So, therefore, it is a double edged weapon. The whole processing is not really maintaining the overall information in it. We are reducing the information. So, in this case, what are we reducing? So, we should know that all image processing may be reducing unwanted information and maintaining, not even increasing, maintaining information of interest. And it may be very risky that while maintaining and while reducing the information, we may be actually reducing the information of interest as well. This is the trade off of all engineering. This is what we are doing actually. So, we are not generating a magical gain out of the image processing. We work with it, but I really frankly tell you what is going on. We should not be very unnecessarily enthusiastic about it, that we should know what we are doing basically. We are doing improvement or only maintaining what we want to have. So, in this case our interest might be, as I said, say getting the area of clouds beyond the horizon kind of situation and say some natural. Now, we are just trying to smoothen it out so that the thresholding operation can be done easily, or any segmentation can be done easily, or the boundaries can be made bigger than original. Now, in this case, if you see the boundaries are now somewhat smoother and simpler than original. So, a machine can handle it easily as a global kind of entity, that okay, there are just two areas, there is one cloud or maybe some river which is also white. So, we may just divide the whole image into three entities, 1, 2, 3, one greenery, say second cloud or sky situation, the third say natural water. If that is the interest, somebody say why you had 8-bit images? That is what the binarization or reduction of information is. We are actually interested in only 3 levels, but we had so many levels, we could not get rid of all the levels, we had to do the screening. It is like selecting say 3 people out of a lot. We are actually interested in 3 people, but we call 100 people. The whole process is reduction. This is what I am trying to say, that the appealing appearance will not be as good as what anybody will assume. So, once you are entering into image processing algorithms, assume that the appearance has no meaning. It is not the appearance that counts now. Though it is an imaging area, people may think, oh, it is a very fascinating, maybe it's very, it will just entertain us. It is not that actually, it is just giving content of interest. So, in this case, smoothing actually is reducing the changes, unwanted or unnecessary changes, and trying to reduce the levels available within the image. Now, that way you can have, say, indexing of 2-3 colors only within the image, and binarization process may become simpler. Okay, details of blur, this is also to the smoothing is also required, as I said, if there is a motion. If there was some motion occurring, all edges will become blur. So, the smoothing operation will generate some smooth boundary in between the entities of interest. Say the sky, if the camera was shaky, the sky and the natural boundary might not be perfect. So, this kind of smoothing could help there. That is the idea. Gaussian blur is one of the blur kind of situation. It comes from Gaussian filter. So, okay, I will just tell you that sometimes these processes are fast. So, those of you who are assuming that this processing may be very time consuming or processor intensive, there are architectural advantages. There are ways of first doing one dimensional processing using one dimensional processor, say row wise and then column wise, and then there are ways of adding them. So, there is a method of decomposing where you can use other kind of linear or one dimensional processors to add the results, and overall 2 dimensional results are possible. So, this is also one of the ways that decomposing can help. And now, as I mentioned just now, while maintaining the information of interest and removal of unwanted stuff is a very risky job. We might be losing even the information of interest, say the edges. When we said segmentation, we are interested in boundaries wherever the entities are changing. The sharp boundaries have to be maintained, and most smoothing filters will do most convolution process will not know where your edge is, isn't it? If you sweep across the floor and you have drawn something or anything, that information is also lost. You may have a clean floor with nothing available in it. So, that is the idea. The idea is that some information will also get lost. The convolution process does not care actually. You may have enhanced something, any filtering, low pass filtering operation will, that is where we mentioned that once the smoothing process was over, we might feel it has lost something, and that loss most of the times the smoothing of filters will actually remove the edges also, the boundaries. When we mentioned we wanted to know the area of, say, sky versus greenery, the sharp boundary has gone or has become weaker. So, where do we maintain the accuracy of results? So, edge preserving is one concept that is intended while doing some kind of convolution. The convolution per se will not maintain the edge. If you are doing low pass filtering, you cannot have high pass filtering. Maybe you make a balance of, say, band pass or something. So, since we are not working in, say, in frequency domain, we are trying to maintain similar results by way of bands of an interest, by calling it, say, edge preserving. We want to see now that there are situations where edges are preserved while getting the smoothing or other effects. Now, there is some filter here which is edge preserving blur filter. Now, you can see, I do not know if you can see the details, the image on the right is actually again a patchy image. Patchy, I use the word as if there are patches, rather than the natural greenery which is occurring, changing at every point. We are having some patches in a manner that, okay, I want to clean, but I do not want to lose the edge. I want to clean, but I do not want to. So, it is in small patches. The results are the details are indicating that we get a mean and variance of the quadrants. Everywhere we choose a quadrant, we choose a mean and variance. We choose a quadrant that, okay, this is the one with the lowest variance. Lowest variance means, that means let us not have lot of variations. The nature has lot of variations, but to me it is all greenery, isn't it? So, we try to preserve the edge only in a small quadrant size. We choose the quadrants of our choice, but we say, okay, in a small quadrant like you are 4 of them, let us see which one is having minimum change. Let us copy them all to 4. It is like choose one quadrant, say suppose you have a quadrant of some vicinity 9. So, you some quadrant size. So, you divide it into 4 parts, choose one which is minimally changing and copy that to all. This is what has been done. The idea is that let us choose a patch with more uniformity is copied to all. So, that the whole thing becomes a patchy, but it is uniform as well, because overall the neighbors are related. And as you can see the image detail, I do not know if it is visible there, you can see there is a loss of originality here again. That is the idea, but the edges are somewhat better maintained than smoothing. That is the idea, than simple smoothing that we did earlier. Now, again this is another one. Now, see the difference here. Some are better in one case, some are better in the other case. So, again this is also edge. That one was on a neighbourhood size, this one is on a again neighbourhood, but it looks for a single pixel's neighbour. There it was quadrant like, here it is nearest neighbour, means let us try to be in, if you see in again in neighbourhood, the central pixel value takes into account of the neighbours, that you be like your neighbour. The idea is be like your neighbour, do not be different from, you cannot be different from your neighbour actually. That is the concept, that is how we can group them into entities. So, this is some details of this can be discussed later on. Okay, then there are some statistical methods that I will just show you, and then only it makes a sense. Median is something many of you must have heard very well, but never thought of it that it could be used for applications like that. There are situations where there are abrupt noise speckles, as we call it. Speckles means, say one particular pixel has gone just bright for some reason. In fact, for X-ray imaging, the detectors here, like your mobile displays and these displays, similarly the flat panel detectors are also there like flat panel displays. What happens is their particular pixel becomes dead, it does not display anything or it does not acquire anything. A particular neighbor has become, a person is like a dead person. Similarly, here you have a pixel which is dead, and it is giving you all time black or white information. I mean, either it is totally on or totally off. So, in those situations what happens is we try to get, now you can imagine a median will give you the result perfectly. You can get the value of the ones which is dead by the neighbourhood, by its median value. So, if you take 9 point median, all over run it for the process, you can take the median and any value say 0 in between will get lost, it will never be replaced. So, what you do in median based processing is that instead of the value itself, you put a median of the neighbourhood in the result image. So, if it is one of the, if the original owner of that pixel value is say dead, but 8 neighbors are there, isn't it? You find a median of that particular value will go out of the median list and any value in between will get. The idea here is, in this case you get a result which is not smoothing, which is not a filtering of convolution type, which is actually replacing one by the other. So, you are able to get the pixels which are dead out of the scene. So, you will find that if in this case there is nothing of that situation. So, some minor change has occurred to the result because of the median operation, that means all pixel values have been altered from the original image. But the difference is that if there were any very speckle noise, means impulsive noise, impulse noise, like any point has become just bright, but other neighbors are correct. So, in that situation this median can help. Unsharpening is also a filter similar to like reverse of smoothing, you can say. Even some appearance, this is not actually used in any enhancement, but this is just to show you that you can create a lot of fun also by applying. In this case you put a random pixel within the sampling window. You choose you say okay, I will just put it is like a kind of like screensavers and all. If you want to make fun out of it, you can see the results here, which is not for any purpose except fun, but shows that how a random choice of a pixel within a sampling window can generate effects of this kind. It is like as if you are seeing say bathroom kind of mirror glass kind of image, or a rainy effect probably from on the glass. So, idea is there is a random change in the placement of pixel.